So your expecteds have nothing to do with your observeds. They came first. You calculate them first. So first you figure out what they are, and then you do observes, and you get some observes, and you compare them. All right. So again, they don't rely upon each other. Expecteds, nothing to do with the observes. All right. So then what Michaela was saying is, say I have my 27 people. I have 27 students, and I think there should be an equal number. So what you're saying is, so if I said I expect there to be no difference in the number of A's, B's, C's, and fails, use DFs. So that would be the no difference or no preference. Make that better. No difference or no preference. Okay, so then, and how do we find them then, you said?
You get all the, what is it, the boxes, you add them all up, and then...
Yeah, you add up all your observed, see how many students you have?
Yeah.
Yep. So then you count up your N, you count up, I'll say find N. Find N total people, and then do what?
And then you divide by each group.
By the number of groups, number of categories. So I would do 27 divided by 4, because I have A, B, C, and I have 4 groups, A, B, C, D, F. So I would expect there to be 7. Why am I having trouble with this? 6.75. I'd expect there to be 6.75 students in each group. I would expect 6.75 to get A's, 6.75 to get B's, 6.5 to get C's, and 6.5 to get D's and F's. If I thought there was no difference, between the grades, like there should be the same amount in each group. Okay, good. Perfect. And they'll put I think it's going to confuse you. I'm going to leave that out. Because I think if I just write that in as a comment, people are not going to understand what I'm saying and they'll just get more confused. So we'll leave that out. Like, you can write stuff about it if it makes sense to you, but I don't want to put that in the general notes without all of the background information that I gave. Incidentally, remember, these notes are for you, right? So I'm never going to see them. They don't need to make sense to me. I don't need to be able to read them. You need to understand what they mean. That's all that matters. Is that it's clear to you? All right. And then next we have our chi-squared matrix. Okay. So what are some things about this one? Yep. We'll have columns and rows. So it's going to have like it'll look like this. Label, 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 label. And then it'll have boom, 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 boom. That's my matrix, right? Let me put that in matrix A. Okay, good. So yeah, you'll have labels on the top. I'll write that in. This is how I do it. So you'll have labels on top. And do we know it's, what are our cues? What are some of the verbal cues? Like, you know, like linear and correlation were for chapter 10. What are some of the things here? What was that?
Mean.
I'm sorry, I didn't hear you.
Mean.
So this is a chi-square matrix. So this one is my data is not numbers. So there's not means. Instead, there are what we call frequencies, proportions and frequencies. So we'll have proportions. Or maybe we might also have frequencies. Well, I mean, they might not call them proportions or frequencies, but they'll give you proportions or frequencies. Because remember, this is how many people fall into different categories. And you might have, what are our tests in memory tests? Oh, the chi-square list. Oh, yeah, we'll talk about that in a minute. So these are tests for independence. I don't know if anybody remembers. Or proportions are the same. That would be another possibility. Okay, so then let's talk about what you were saying before. You said that there is the test. So step 3. Okay, yeah, I'll take that. Step 3. You're going to do stat, test, chi-squared test of matrix A. Good. What else do we know about? What about step 1 and step 2? Right, so step 1 is going to be that O sub I equals E sub I. O sub I is not equal to E sub I. Right, and this one's our claim. H0. Okay, what's step 2? Anybody? That's someone different. Someone else. Can't carry everybody. Stop being lazy, people. Start randomly calling people like Diego.
You have on your critical value,
Mm-hmm. What do I use to find it?
you just look at the problem.
I need to find my degrees of freedom.
Yeah, well.
And which table do I use? Yep, I use, yep. So from the chi-squared table, good. Thank you. It's going to look like that again. And then my degrees of freedom. Anybody remember how to find my degrees of freedom?
Rows minus 1.
Yep.
Times column minus.
Exactly. Good. All right. And then step 4 is kind of regular. Yes. So 4 and 5 are the same as chi-squared list. So really 1, 2, 4, and 5 are all the same as chi-squared list. The only difference is degrees of freedom. Does that sort of make sense? Those are all the same. Right, the only thing that's different is step 3 is different and degrees of freedom is different. Otherwise, it's the same as a chi-squared list. And then we have the expected values. That's different. So that's a whole other thing here. Expected values, which is part of step 3. So maybe I should put them in there. I'll put them, you know what, I'll put these at the bottom. Well, no, I kinda like to put them there, cause it's, it matches up with, what we did for the customer list. Expected values. Also in step 3. Okay, so how do I find those? I want to take a second, check in and try to remember how do I find my expected values.
Professor,
Yes.
do you supposed to write second matrix so you can calculate that?
Right, so if you want to put that in there, how to get to matrix, second matrix, and then over to edit, that would be a good thing to put in there. So I can put that in. Maybe we'll put that in over, add that in. So second matrix. Edit. Like that. Okay. And then we have our expected values. Okay, so which expected values do we need to find? Someone over there?
I have it here, but I don't know how to explain it.
Okay. So which expected values do we need to locate? Right, so just say E11.
E11
Yep.
and E33.
Yeah, so the first one and the last one. So it may not always be 3, 3. It's whatever the last row and the last column is. So we need to find the first and last. In the matrix. So we need to find E11. That's the first row, first column. And how do we do that? Anybody remember how we do that one?
The row total times the column total over the whole matrix total.
Right, row total times column total over, what do you call the grand total? Great. Now let's find how to find the last one as well. All right, perfect. And I think we can look at the last one, ANOVA. ANOVA. That's a little bit shorter. What do we know about ANOVA?
It has only top or side categories.
Yeah. So it has 3 lists. So labels only on top or side, not both. So it'll be like label, 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 and then data. Right? Could be equal, might not be equal. But there's nothing here. Does that sort of make sense? Okay, good. Great. What's another way of telling? Some mentioned it earlier. Yep. It'll have the word mean in it. Mean or average. It won't have standard deviation probably because well, but it should say mean or average in it, for sure. Okay. Good. All right, so what's my first step? This one?
H naught and mu1 equals mu2 equals mu3.
U1 equals U2 equals U3, however many means you have, dot, dot, dot. And H1 plus U. H1 is what, folks? Someone else? What was that? Yeah, at least one differs. Great. Step 2. What's up with step 2? I find my critical value. What was that? Yeah. So my critical value, I don't really have a critical value. Instead I'm going to use alpha. Use alpha. And compare to p-value. So this is going to be step 4. Step 4 will compare to p-value. Right, so again, remember, so if the p-value is less than alpha, it's unusual. We'll come back to that in a minute. I'm going to move on to step 3. Sorry, how do I find my test stat? Yeah, stat test ANOVA. And actually, I'm not even going to care about the stat test. Can't spell apparently. ANOVA of L1, L2, L3 are many lists I've got. So it tells us I should put things in lists, and then get p-value. Because in step 4, if the p-value is less than alpha, it's unusual. Unusual.
Do you want us to write down that too?
No, it's okay. I feel like getting it from there is not intuitive, so it's not really going to be all that useful, yeah. And then step 5, is enough evidence to reject claim. Means Nathan, haven't heard from you all day today. Reject claim means or what?
Means are the same.
Yep. Okay. Yeah, the claim is going to be H naught. So remember, for all of chapter 11, your claim is H naught. For all of chapter 10, your claim is, sorry, for all of chapter 11, your claim is H naught. For all of chapter 10, your claim is H1. Any questions at all?
Chapter 11 is going to be H now.
Yeah, chapters 11 is H naught. Maybe we'll go back here and we can talk about that. How's that? some problems.
Yeah, maybe it's a
I'll start with the first one.
not too sure. Not on the top of the song. Like everything makes
Okay. Let's try this one. Oh, there we go. Everybody compute your, okay, so what kind of problem is this one? I'll take a second to figure out what kind of problem this is. What is it? Right. Say it again, louder, Nicole.
It says the proportions are as expected, so it's chi-squared list.
Right, proportions are as expected. That's a chi-squared list problem. Because I don't have a matrix. I just have one line of data. Right, so I just have observed. I have 3 categories. So this is a chi-squared list. These are my 3 categories. So I need to find the expected values. So everybody compute the 3 expected values, the expected values for these ones. Do that now. So let's see what these are. So I have my observed, which are 98, 94, and 8. And any find my expected. So my expected, so we said 38% plane, 53% car, and I expect 9% by other. So if I expect, these are the percentage I expect, but I can't compare 98 to 0.38. That's not fair. I'm comparing the number of people I expect to the percent of people I expect. You should be comparing people to people. So, Michaela, how do I do this again?
200?
Huh?
What percentage?
I'm sorry, what did you say?
200 times the percentage?
Yeah. 200 times percentage of each one of these. So this will be 78, 103, and 18. Good? All right. Great. Let's look at another one. Maybe.
I got 106.
Oh, I'm sorry. I screwed up. Yeah. Somehow I added 3 and 3 and got 3. My bad. Okay. Let me go to. Or do you want to just do this one problem? Okay. So why don't we proceed with going ahead and doing the actual problem. So go ahead and oh, I guess you have to go see the problem. So you have almost everything you need. You have that N is 200, and my alpha is 10%. And you're testing that the proportions are as expected. So everybody work on that one. Okay, so let's take a look at this one. So, number 1. Angela, what's number 1? Step 1. Yep, H naught is O sub I equals E sub I. And H1 is what?
O sub I doesn't equal E sub
O sub I does not equal E sub I. Good. And then this is chapter 11, so which one's my claim?
I. H naught.
H naught is my claim, great. Step 2. Destiny, go ahead, what's step 2?
So recognize your EF, which is the number of categories, which is 3.
Okay, so then you still find your critical value, which is what?
4.605.
4.605. Okay, step. We found expected values already, so then step 3. Diego, go ahead.
So you gotta use the formula that x squared equals O sub I minus E sub I squared.
Yep, so divvy them.
Oh. 98 minus 76. Divided by 76.
Plus.
94 minus 106.
So you have to write this out. You don't write this out,
106.
that's, let's see, it's probably 17 points probably for this problem, and that's probably gonna take 4 or 5 points. If you don't write this out. Okay, and then keep going.
Plus A minus 18 squared divided by 18.
And what did you get?
And that's 7.478.
7.347.
478.
478. So, okay, so it's over here.
Yeah.
7.348.
Then you're gonna inject this.
Oh, and we have moved somebody else. So,
I don't know why.
Alondra, step 4.
H naught.
Check H naught. And then step 5. Nicole?
There is enough evidence to reject the claim that the proportions are as expected.
Great. Did anybody else get a different number for number 3, for part 3?
Yeah. 13.282.
What'd you get? 13 point, 13.32?
Oh, yeah, I got that.
Yeah,
I changed it.
13.28?
Yeah.
Okay. Seems reasonable.
make sure you put it in correct in the
Well, no, I didn't listen to that.
Oh, did you do a chi-square matrix on it?
Yeah.
Yeah, that you can't do that.
That's what I did.
Yeah. So even when you send they'll like be like an error, action, they say action required for
Okay, what am I?
then you so like good like this. Wait.
Right, so it's really important that that you write down what you did here, right? Because that's a lot of the problem, right? That's a lot of the points. Okay, great. Let's take a look at another one. So here, I would like everybody to just compute the expected values. What are the expected values? So take a look at this one. Find the expected values. So these are blank. Fill them in. How do we find these ones? Well, they didn't give me any percentages, but they did say equally likely. Everyone see the equally likely up there? Yes?
Yeah.
So how do we find them? Divide what?
63 by 3.
63? Sample is 63 by how many? Ryan, you said divide by how many? 3, because it's 3 categories. So 63 divided equally amongst 3 categories, and you should get what? 21. Yep. Good. Wow. All right. Next. probably should do one, huh? I'll tell you what, let's do this, yeah, okay, let's do this one. Let's have you just do this. I want you to find the expected values that you need to find. And so just do step 3. Because steps 1, 2, 4, and 5 are exactly the same as the one you just did. So just do step 3. Right? Your 2 expected values and the test stat, chi-squared.